Yes, dear students, let us we study today about nomenclature of coordination compounds. In the last class, we have also studied the list of the ligands and their names. The ligands are classified based on the negatively charged, the neutral molecules, and also positively charged. Now, to know about the nomenclature of coordination compounds, you know how to name the simple compounds. For example, sodium chloride. How we name it, the same way we write it, like NaCl. Calcium chloride, CaCl2. Aluminium sulfate, Al2SO4 thrice. But in naming and writing the coordination compounds, it is different. Writing the formula of a compound is different from naming the coordination compound. Now, let us we study first what are the rules to be followed while writing the formula of a compound. Now, to know about it, the first one, it says the central atom is written first, anionic ligands are listed next, which are followed by the neutral ligands. Now, if I take an example below, the cobalt complex, here the chloro, bromo and iodo are the negatively charged ligands and amine is a neutral ligand. Therefore, negatively charged ligands are written first and then the neutral ligand. Similarly, in the second complex also, carbonato ligand is written first, which is negatively charged, and amine is written next, which is neutral in nature. If there are more than one anionic ligands, they are listed in the alphabetical order according to the first symbol of their formula, but not their names. Similar procedure is followed even for neutral ligands. To know about it, now let us take a first complex, that is a cobalt complex. In this complex, chloro, bromo, iodo are the three negatively charged ligands. Among the three, the B comes first, next comes C, next comes I. Therefore, bromo is written first and Cl and then I. The third point, the polyatomic ligands are written in parentheses. Now, ammonia is a ligand which contains polyatomic. So, therefore, it is written in the bracket. Carbonato ligand is written in the bracket and so on. There should be no space between the ligands and the metal within the coordination sphere. So, in the coordination sphere, which is written in the square bracket, the metal ion and the ligands are written continuously and there should not be any space between the two. The fifth one, the charge on the complex ion is indicated outside the square bracket as a right superscript with the number before the sign. Here, if a cationic complex is there, the cationic charge should be written like 3 plus but not plus 3. It should be written 2 plus but not plus 2. Similarly, for anionic complexes also, it should be written 4 minus but not minus 4 and so on. Now coming to the procedure for writing the formula of coordination complex is different from the procedure of naming it. While naming the coordination compounds, IUPAC rules are followed. So these rules are given in the year 1976. Now what are these rules? Let us study one by one. The first, it says the cation is named first and then the anion. However, the neutral complexes are given a one-word name. That means here it clearly says, for example, in simple molecules, sodium chloride is, if you write the formula, the cation sodium is named first and then the chloride ion. In case of calcium chloride, calcium is named first and then the chloride. In the similar manner, even in the complex also, cation of the complex is to be named first and then the anion. Now the second point here, in naming the coordination sphere, the ligands are named first and then the central metal ion. Yes, it says, suppose if I take a complex ion, in the complex ion, ligand should be named first and the metal ion. For example, it should be cyano, iron 2, bromo, copper 2, so like this. Now, the various ligands, the names of the negative ligands end in O, positive ligands end in IUM, and the neutral ligands are named as such. I have given an examples here. So the Cl minus is written chloro. So Br minus is written bromo. The Cn minus cyano, carbonato, sulfato, nitrito N. In case of NO2, the nitrogen and oxygen both have the coordinating sites. Here the nitrogen is given a lone pair of electron, hence it is written nitrito N. Acetato, hydroxo, the thiocyanato S. Thiocyanato S means in SCN minus, sulfur donates a lone pair of electron. Suppose in the nitrogen donates in this, it is written as NCS minus, which is called thiocyano N. In case of the positive ligands, NO plus is called nitrosonium ligand, NO2 plus is called nitronium ligand, and in case of neutral ligands, ammonia is called amine, carbon monoxide is called carbonyl, nitric oxide is called nitrosyl, water is called aqua, and so on. The ligands are named in the alphabetical order irrespective of their being neutral, negatively or positively charged. This is very, very important rule. While writing the formula of a coordination compound, the negative ligand should be written first and then the neutral ligand. But while naming the coordination compound, irrespective whether it is negative or neutral, it should be named as in alphabetical order. Now, in case the example I have written below, PtClNO2 NH3 4 times the 2 plus. In this case, while writing the formula, I have written negative ligands first and amine ligand, that is a neutral ligand, later on. But while reading this, we should name tetramine because ammonia A comes first there. Hence, tetramine chloro nitrito N platinum 4 cation. Now, let us take the other aspects. When more than one simple ligand like cyanide, the chloro, nitro, ammonia, water, etc. of a particular kind are present in the complex, the prefixes di, tri, tetra, penta, hexa are used to indicate their names. Here I have given K3AlCl6. Here the chloro ligand, how many are there? The 6. Hence it is called hexachloro. Tetramine. So like this you can give the numbers. If the ligands have complex names such as ethylene diamine, triphenyl phosphine, ethylene diamine tetraacetato, etc., which themselves contain di, tri, tetra, etc., their names 2, 3, 4 are indicated by prefixes such as bis, tris, tetrakis, and so on. Now the example is written below. The copper is linked to ethylene diamine. So ethylene diamine itself is having the word di, hence since the two ethylene diamines are attached to copper, therefore it is called bis-ethylene diamine. In case of dipyridine, so it is called tris-dipyridine. Now coming to the another rule of IUPAC, when the complex is anionic, the name of the central metal atom ends in ate. For cationic and neutral complexes, the name of the metal is given without any characteristic ending. Now, the example I have given, KPtCl5NH3. Here, potassium is a positive ion and the complex ion is a negative ion. Now, this is named as potassium amine pentachloro platinum 4. Similarly, another example, Ca2FeCN6. It is written as calcium hexacyanoferrate 2. Now the question is, why in case of platinum is written platinum 4 and Fe is written as Fe2? It is very simple. We have studied in the earlier class. So the 5 Cl are there, hence it is 5 minus. So K, only one K is there, its valency is 1 plus 1. So 5 minus plus 1 becomes minus 4. Therefore, the valency of platinum must be 4. Therefore, it is written platinum 4. In case of Ca2FeCN6, 6 cyanide means 6 minus. So calcium valency plus 2 into 2 is plus 4, minus 6 plus 4 will be minus 2. Therefore, Fe must be plus 2. Hence, it is written ferrate 2. Promonium sulfate. It is written as tetramine copper 2 sulfate. It is written as pentamine chloro cobalt 3 chloride. Now here I have given the element and how it should be abbreviated in cationic complex and how it is abbreviated in anionic complex. In case of cationic complex, these elements are named as such: chromium, zinc, aluminium, iron, copper, etc. Whereas in case of anionic complex, these are named as chromate, zincate, aluminate, ferrate, cuprate, and so on. Now coming to the point, the ligands which act as bridges between the two metal atoms, the Greek letter mu is written before their names. In case of more than one different bridging ligands, the prefix mu is written in all the bridging ligands. Now let us discuss this statement with the following examples. Now in the first example, iron is connected to water molecule. So two iron atoms are there, the two water molecules are there, and two iron atoms, they are linked, iron ions linked to OH groups. So how many OH groups are there? 2 OH groups, hence it is written dimu-hydroxo. What are the total water molecules? The 8, hence it is octa-aqua. How many iron are there? 2, di-iron. What's the valency of iron here? It is in +3 state. Why it is in +3 state? 2F, the sulfate is there. The sulfate -2 into 2 -4 and 2 OH -2, it becomes total -6. So -6 is balanced by 2 Fe. Therefore, each Fe carries +3 state. Hence, the iron 3 sulfate. Coming to the second example. In the second example, palladium is linked to 2 Cl atoms and also it is linked to the triphenyl phosphine. So therefore it is the two Cl atoms are linked between the two palladium, hence it is written dimu-chloro. The next dichloro, because the Cl are attached to palladium, and the triphenyl phosphane, this ligand itself is having tri, hence the word bis should be used. Bis triphenyl phosphane. How many palladium? Dipalladium, and it is written 2. Oxidation state of palladium is 2. So how the oxidation state of palladium is 2? So how many are there? The 4 Cl are there. So 4 Cl means 4 minus. So each palladium will be plus 2. Therefore it is written palladium 2. Case of the third example, if I take here, between the two cobalt, you have two different ligands. One is the amine and another is the nitrito. Now, how this should be named? So, here 2 cobalt, totally hexamine, the octamine, and this. Here, for every bridging ligand, you have to use the word mu. So, this NH2 group is called amido group. Hence, it is known as mu amido, mu nitrito, and octamine dicobalt 3 nitrate. It is called because NO3, how many are there? 4 NO3 means 4 minus. So NH2 and NO2 carries the minus charge. So totally the 6 minus will be there. Therefore each cobalt valency is plus 3. Therefore it is written cobalt 3 nitrate. Similarly, the next example is mu hydroxo, mu imido, tetrakis, ethylene diamine, dicobalt, iron 2 dicobalt 2 ion. So like this, I have given the various examples. The next comes the another point. If a ligand can coordinate through one or the other atom, then the point of attachment of the ligand is indicated by putting the symbol of the atom after the name of the ligand through which coordination occurs. This is already I have told you. NO2 minus is called the nitro group, can donate either through nitrogen or through oxygen. If it coordinates through nitrogen, it is written NO2 minus called nitrito N. If it coordinates through oxygen, it is written ONO minus called nitrito O. Similarly, in case of SCN minus thiocyanato, here the coordination is through sulfur, hence it is called thiocyanato S. NCS minus, here coordination is through nitrogen, hence it is known as thiocyanato N. Now let us explain this by taking some of the examples. CONO2 thrice, NH3 thrice. How this should be named? So it is named triamine because A. The triamine trinitrito. The 3 NO2 groups are there. Hence it is trinitrito N cobalt 3. Similarly, the next one COONONH3 5 times SO4. It is called pentamine nitrito O cobalt 3 sulfate. Similarly, the next one is known as ammonium hexathiocyanato S platinate 4. Coming to the next point, geometrical isomers are named by the use of the terms cis to designate adjacent positions and trans to designate opposite positions of the ligands. For square planar complexes, 1, 4 and 2, 3 positions are cis positions and 1, 3 and 2, 4 positions are trans with respect to each other. The next, if a dextro and levorotatory optical active compounds are designated by plus and minus or by small d and small l respectively. So if I take a complex K3 iridium IR oxalato complex C2O4 thrice is named as potassium dextro. It is a dextrorotatory compound, hence it is written plus or D trioxalato iridate 3. So if I take for complicated molecules, abbreviations are generally used, like ethylene diamine is abbreviated as EN, pyridine is abbreviated as PY, acetyl acetonato is given as ACAC, and so on. Now I have given here some of the examples and their names. So students, you practice these examples and how to write the names of the compounds. Similarly, I have given here the various, the bridging complexes and their names. You practice it and then you can write the names very well and also the formula of the compounds. Thank you.